Hello friends, today we will start our lesson from a new chapter titled Integrals. This is chapter number 7 and our video is the first video on the series and it is part A. In this session we will not only introduce this subject but also solve few problems of marks 1, 2 and 3. There will be total of 22 marks in your board examination. So this is a very important chapter. Very simple, but you have to follow 3 steps. First, you have to understand the concepts. Second, you have to remember the formula. Third, and most important is you have to practice all the numerical problems. This is pertaining to reduced syllabus for the year 2021. The retained portions are introduction, integration as an inverse process of differentiation, methods of integration, integrals of some particular functions, integration by partial fractions, integration by parts, definite integrals, fundamental theorem of calculus, evaluation of definite integrals by substitution, and some properties of definite integrals. The deleted portions are integral of square root of ax square plus bx plus c into dx, comma, integral ax plus b into integral of square root of ax square plus bx plus c into dx. Definite integral as a limit of a sum. Let us start. Integrals. Integration is the inverse process of differentiation. In differentiation, we are given a function and we are required to find its derivative or differential coefficient. In integration, the derivative of some function is given and we are required to find the function. Derivative is given and we are required to find the function. Symbolically, if d by dx of capital F of x equals f of x, then we write integral f of x dx is equal to capital F of x plus c, where the symbol elongated s as shown in the screen stands for integral of and dx stands for with respect to x, differential with respect to x. F of x, the function which is to be integrated, is called the integrand. The constant c is called the constant of integration. F of x, note f of x plus c is equal to, plus c is the integral of a function fx is also called primitive or antiderivative. So I will repeat, note f of x plus c, the integral of a function fx is also called primitive or antiderivative. This we will be using, the term antiderivative will be using in solving the numerical problems. For the sake of convenience, we mention the following symbols, terms of oblique phrases with their meanings as given in the table shown. Symbol, terms and phrases, and the right hand side, the second column is meaning. Integral f of x dx, it is read as integral of f with respect to x. Next item. F of x in integral f of x dx. So the term f of x is called the integrand. And x in integral f of x dx is called the variable of integral. So x is the variable. So if you use the term integrate, it means find the integral of. Similarly, an integral of f means a function f such that f dash x is equal to f of x. So integral of a f is means a function of f such that f dash is equal to f of x. Integration. Integration is the process of finding the integral. Then finally, constant of integration. Constant of integration is any real number and it is represented by C, capital C usually. Capital C means it is a constant of integration and considered as constant of a function. Please remember all these terms which we will be using in this chapter very frequently. A few standard formulae of integration are also to be remembered. This is very important for solving the numerical problems. For your convenience, we have also recollected the derivatives which we have studied in previous chapter as well as in the class 11. So derivatives are given in column 1 and integral, that is the terms and the integration used in this chapter, that is chapter number 7, are given in the right hand side column, that is column number 2. Let us start. D by dx of x to the power of n by n minus 1, n by n plus 1 equals x to the power of n. We know from our previous knowledge, differentiation of x to the power of n plus 1 divided by n plus 1 is x to the power of n. Therefore, integral of x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1. So in differentiation, we subtract the power and write it. Here we add 1 and this is applicable. Integral x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1 plus c is n is not equal to minus 1. See, if n is equal to minus 1 in this term, so the denominator becomes 0, which is not defined. Hence, this formula is used only for all values of n except n minus 1. Similarly, d by dx of x we know as 1. So, integral of 1x dx is x plus c. The third one, d by dx of log x, we know that it is 1 by x, whereas integral of 1x dx will be equal to log of mod x plus c. You please remember, whenever you are mentioning log is always for a positive value. Log is always positive. And here in this equation, x is not equal to 0. See, denominator x is not equal to 0. If x becomes 0, then it is not defined. Then d by dx of c is equal to 0. Therefore, integral 0 dx is equal to c, that is constant. Then, having defined the power rules, these are all power rules. This is called power rule. That is integral x to the power of n dx into dx equal to x to the power of n plus 1 divided by n plus 1 plus c is a power rule. Now, we will take up trigonometric functions. We know d by dx of sin x is cos x, whereas integral of cos x dx is sin x plus c. So, this is reverse of differentiation. Therefore, d by dx of minus cos x is equal to sin x. So here you see, earlier we were using d by dx of cos x as equal to minus sin x. But here the sin is taken inside the bracket and the right hand side is sin x. Therefore, integral of sin x dx is equal to minus cos x plus c. You have to remember that. Then dy dx of tan x, we know it is secant squared x, whereas here integral of tan x dx is equal to minus log of mod cos x plus c. And in other form, we can state integral of secant squared x dx is equal to tan x plus c. Then the next term is cosecant x. Dy dx of minus cosecant x is equal to cosecant x cot x. That we have studied. So integral of cosecant x dx is equal to log of mod cosecant x minus cot x plus c. That is also simplified as this can be cos x minus cot x can be simplified as log of tan x by 2. The next term is d by dx of secant x. So secant x, d by dx of secant x is secant x tan x. Therefore, integral of secant x is log of mod secant x plus tan x plus c. This can also be written as log of modulus tan of within brackets pi by 4 plus x by 2. It is in terms of half angles plus c. The next term is d by dx of minus cot x equals cosecant square. We know that. Therefore, integral of cot x dx is equal to log of mod sin x plus c. D by dx of ex. These are all till now we have seen only the trigonometric functions. Now we will see the exponential function. D by dx of e to the power of x is equal to e to the power of x. That is integral of e to the power of x dx. That is equal to e to the power x plus c. Finally, the last term in the standard formula is d by dx of ax, a to the power of x divided by log a, that is equal to a to the power of x, that is equal to integral a to the power of x dx is equal to, that is integration of a to the power of x dx is equal to a to the power of x divided by log a plus c. You please see, observe here on the complete after integration, constant of integration c has to be added for each and every after each and every integration process. This is very important. You should never forget to add plus c, plus capital C, which is a constant. We have also given some important formulae on integration, which are very frequently used in solving numerical problems. The most, it is given under the heading most important function. Integral of dx by x square minus a square equals, if the function is given like this, it is after integration, it is 1 by 2a into log of x minus a divided by x plus a mod. So because log is always positive, we have to write it within modulus side bracket. Plus c is the constant of integration, which has to be written after each and every integration process. The next is the integration of dx by a square minus x square. So we write here 1 by 2a into log of a plus x divided by a minus x plus c. Then the next function is integration of dx by x square plus a square. That is equal to 1 by a. You have to say, because a is added here, we have to write 1 by a. For tan inverse term, it is 1 by a, tan inverse of x by a plus c. Or it can also be written, if we put the value of a as 1 in this equation, it will be integral of dx by 1 plus x square. A as 1, 1 plus x square will be is equal to tan inverse of x plus c. Then the next function is dx divided by, here the next three functions are the denominator, wherein the denominator is under square root of. So these three functions are dx by square root of a square minus x square. See, this is also x into dx by x square minus a square and dx by x square plus a square. This is under root. Therefore, dx by x square plus dx by under root a square minus x square is sine inverse of x by a. This you remember. So when a square minus x square is there, it is sine inverse of x by a plus c. If we put the value of a as 1, we get integral of dx by square root of 1 minus x square is equal to sine inverse of x plus c. See, these terms are after putting the value of a as 1, these three terms on the right hand side. Similarly, the integration of dx by x into square root of x square minus a square is 1 by a secant inverse of x by a plus c. That is, if you put a as 1, it will be secant inverse of x plus c. Now finally, the integral of square root of the dx divided by under root x square plus a square. So that can be written as equal to log of modulus x plus square root of x square plus a square plus c. See, this under root, you have to write log of x and x square plus a square. Whatever is given here, it is written as a second term. So, numerator. Now, we will define hitherto the previous three cases were the function was under square root, that is a square minus x square here, x square minus a square under root, and here it is square root of x square plus a square. Now, next three cases we will be taking where the function is numerator root formula. So there is a root in the numerator itself. Therefore, integral of under root square root of x square minus a square into dx is equal to, we have to write here, you see the formula, there is method here, equal to x by 2 square root of whatever is there in the square root here, same thing you write. Suppose x square minus a square is here, here also it is x square minus a square minus, because minus is before a, you write minus here, and a square by 2. So a square by 2 into log of x plus square root of same value x square minus a square. Here you have to fill up between the modulus sign plus c. Next is integration of a square root of a square minus x square. Again, this is equal to x by 2 into square root of a square minus x square. Here you have to write a square minus x square plus a square by 2 into sine inverse of, see this is the formula for sine inverse. See here also you see it is 1 minus x square. So you have to write it is similar to sine. So sine inverse of x by a plus c. Next is square root of integral of square root of a square plus x square dx. That is equal to x by 2 is, see everywhere all the three, when the square root term is under square root, you have to write the first term as x by 2 in all the three cases, and the given function itself as in the under root, that is in this third case a square plus x square plus a square by 2 into a logarithm of x plus under root the given function. So as it is, we have to write into mod plus c. Then algebra of integration. Having studied about the standard formulae of integration, let us recollect or also specify algebra of integration. That is integral of c is a constant of f of x of dx equals c is outside. C, the constant is taken outside f of x dx. So this is so far as integration of a constant of a function where coefficient is a constant. So the next item in this is integration of f of x plus gx. There are two summation of function of x. So here the algebraic rule says it can be separated. Therefore, this becomes integration of f of x dx plus integration of gx dx. This term also we will be using in the numericals for while solving numerical problems. Then the third case is where a coefficient is multiplied to the f of x. There are two functions fx and g of f. F of x and g of x. The coefficient of f of x is a and coefficient of g of x is b into dx. So integral a f x plus b gx into dx is equal to, here the coefficients are taken outside the integral sign. Therefore, it becomes a into integral fx dx plus b into gx dx. Gx. And the next is, we had previously seen summation, and in this, the last case, it is differentiation. Therefore, integral of fx minus gx dx is integral of fx dx minus integral of gx dx. All these formulae you have to remember. Please remember and practice it frequently, repeatedly rather. Standard forms 1-mark questions. These are all very simple problems which can be solved just by application of concepts and remembering the formula. Please practice it because they are very simple. Question number 1. Write an antiderivative for each of the following functions using differentiation. First is sin 2x. Solution. The antiderivative of sin 2x is a function of x whose derivative is sin 2x. We know that d by dx of cos 2x is minus 2 sin 2x. Therefore, sin 2x is equal to sin 2x, just retain on the left side, minus you move to the right side. Then if 2 goes to the numerator of the other side, then it will be sin 2x is equal to minus of 1 by 2 into d by dx of cos 2x. That is, therefore, the antiderivative of sin 2x is minus half cos 2x. Question number 2. Cos 3x. That is, write an antiderivative of cos 2x using differentiation. So, the antiderivative of sin 2x is a function whose the antiderivative of cos 3x is a function of x whose derivative is cos 3x. Therefore, we know that d by dx of sin 3x is equal to 3 cos 3x. Therefore, cos 3x, that is the term on the right hand side, retaining, which is asked in the question, retain cos 3x on one side and move this 3 to the denominator. So, the right hand side becomes 1 by 3 into d by dx of sin 3x. Therefore, cos 3x is equal to d by dx of 1 by 3 sin 3x. Therefore, the antiderivative of cos 3x is 1 by 3 sin 3x. Third question. E to the power of 3x. That is, write an antiderivative of e to the power of 2x using differentiation. The antiderivative of e to the power of 2x is a function of x whose derivative is e to the power of 2x. Therefore, we know that d by dx of e to the power of 2x is 2 into e to the power of 2x, because derivative of e to the power of x is e to the power of x itself. Therefore, because the power is 2x, we get 2 here. Therefore, e to the power of 2x, that is the term on the right hand side, e to the power of 2x is equal to 1 by 2 into d by dx of e to the power of 2x. Therefore, e to the power of 2x is equal to d by dx of half into e to the power of 2x. Therefore, the antiderivative of e to the power of 2x is half e to the power of 2x itself. Evaluate. Question number 4 is evaluate integral of within brackets 4 into e to the power of 3x plus 1 into dx. This is given question. You have to evaluate. Solution. So the given function, you write down here, the given function is integral within brackets 4 into e to the power of 3x plus 1 into dx. Therefore, we had this is a constant, a is a constant, hence it jumps and comes outside. So it is 4 into integral e to the power of 3x into dx, that is summation formula. You can separate these two terms, e to the power of 3x dx plus integral, this integral of 1 into dx. Now we have to remember the standard formula to find the integral of these two functions, that is integral of e to the power of 3x dx and integral 1 dx. We know that e to the power of 3x, integral e to the power of 3x is e to the power of 3x divided by 3. Therefore, we have to remember this formula. The 4 into e to the power of 3x by 3 plus x, integral of 1 dx is x. So, plus c is the constant of integration. So after integration, that is integration you have completed. After writing that integration, you have to write plus c, which is constant of integration. This is the answer. 4 by 3 into e to the power of 3x plus c is the answer. Next question. Evaluate. Integral x square into within brackets 1 minus 1 over x square dx. Solution. Given function is written as it is. Given, you write here given integral x square into 1 minus 1 over x square dx. Therefore, that is equal to x square integral x square into, simplifying this, you take LCM, x square as LCM here, x square, then x square minus 1 over x square. Simplifying the terms in the bracket, we get integral x square into x square minus 1 divided by x square into dx. This becomes, if you separate it, if you separate this term, x square gets cancelled, you get 1 minus 1 over. See, this x square and this x square get cancelled. Therefore, we get x square minus 1, whatever is there in the bracket. So, it is x square is written x square dx, this x square dx minus 1 in integral into dx, 1 dx. Therefore, x square, integral of x square dx is, using power rule, we get x cube, that is x square plus 1 divided by 2 plus 1. Therefore, it is x cube by 3 minus 1 of dx. Integral 1 of dx is minus x plus constant of integration. Next question. Evaluate integral 2x square plus ex dx. So here once again there is summation. You have to separate these two terms. So solution given integral 2x square plus e to the power of x within bracket written as it is into dx. Therefore, 2, the constant, you take 2 outside, this becomes into integral x square dx as it is plus integral e to the power of x dx. This is just by separating the two terms. Now we have to use power rule. So 2 into x square, integral x square dx is x cube by 3 plus e to the power of x as it is plus c. This is the answer. Question number 7. Find antiderivative of cot square x with respect to x. Therefore, solution is cot square x is equal to, we know cot square x is cosecant square x minus 1. That is remembering the trigonometric relationship. Therefore, antiderivative of cot square x is equal to minus cot x minus x plus c. This is, that is, dy dx of cosecant square is minus cot x minus x, that is dy dx of 1 is x plus c. Question number 8. Find an antiderivative of square root of 1 plus sine 2x with respect to x. Therefore, given is square root of 1 plus sine 2x. Therefore, that 1 can be written, we know sine squared x plus cos squared x is 1 from the trigonometric relation. So, this 1 will be substituted as sine squared x plus cos squared x, and sine 2x will be expansion. You have to do the expansion of sine 2x. Sine 2x is 2 sine x cos x. Therefore, this will be sine x plus cos x whole square. That is, this is, if suppose this is a square and cos square x is b square, a square plus b square plus 2ab, where a is sine x and b is cos x formula, and we are substituting it as a whole square, sine x plus cos x, a plus b whole square. So, when this is there, the square root and this square sign get cancelled and we get sin x plus cos x. Therefore, the right hand side is sin x plus cos x. Therefore, antiderivative of sin x plus cos x is cos x minus sin x. That is sin x, the integration of sin x is cos x and cos x is minus sin x plus c. Next question. Evaluate integral within brackets d by dx of e to the power of 5x dx. Therefore, e to the power of, we know using the formula, d by dx of e to the power of 5x is 5x e to the power of 5x itself. So plus c. Next question. We have the 2 marks questions from the standard forms part. So these questions will be in standard forms. Question number 1. Write an antiderivative for each of the following functions using differentiation. First question is ax plus b whole square. Therefore, the antiderivative of ax plus b square is a function of x, whose derivative is ax plus b square. We know that d by dx of ax plus b, that is the given equation, whole cube is 3 into a into ax plus b square. We are supposed to get ax plus b square on the right hand side. That is why from the given equation we are considering we are changing it instead of square, cube. So differentiation is 3ax plus b equals 3a into ax plus b whole square. Therefore, that is equal to ax plus b square. This term on the right hand side equals to 1 by 3a into d by dx of ax plus b whole cube. Therefore, ax plus b whole square is equal to d by dx of 1 by 3a into ax plus b whole cube. Question number 2. Given is sin 2x minus 4 e to the power of 3x. The antiderivative of sine of 2x minus 4 of 3x, which is a given function, is a function of x whose derivative is sine 2x minus 4 into e to the power of 3x. So we have to find the derivative. We know that d by dx of, because sine 2x is there, we have to consider d by dx of minus half cos 2x. So sine 2x is, we have to consider the function minus half cos 2x minus 4 by 3, that is in 4 by 3 into e to the power of 3x. That is equal to what we get if we take derivative. It is 2x cos it minus sine, so it is sine 2x. 2 gets cancelled, we get sine 2x minus, because 3x e to the power 3x is 3, so 3 gets cancelled, 4 e to the power of x. Therefore, the antiderivative of sine 2x minus 4 e to the power of 3x is minus half cos 2x minus 4 by 3 e to the power of 3x. Next question. Evaluate. Integral ax square plus bx plus c into dx. Given ax square, integral of ax square plus bx plus c, we have copied it as it is. Therefore, the given equation becomes coefficient of variables should be taken outside. Therefore, we take here in this term, we take a into integral of x square dx. Then in the second term, that is bx, we take b outside the integral sign and write it as b into integral x dx. X is this x and this dx plus c. C into integral 1, if we take c outside, 1 remains, 1 into dx. So that becomes a into this x square is integral of x square is using power rule x cube by 3 plus b into x square, that is again power rule x square by 2 plus cx plus c. Therefore, simplifying ax cube by 3 plus bx square by 2 plus cx plus c. Question number 4. Evaluate integral square root of x minus 1 over square root of x whole square into dx. This is the given equation. So, given integral, we are writing the given equation as it is. That is, given integral within brackets square root of x minus 1 over square root of x into whole square dx. So, you have to expand this. That is a minus b whole square. A square plus b square minus 2ab. Using that is a minus b square. A minus b whole square is given by a square plus b square minus 2ab. So, a square is root of x whole square is x, b square is 1 over root x whole square, that is 1 over x, minus 2ab is minus 2 into a is root x, b is 1 by root x. Those two roots get cancelled and we get 2. Please write it step very carefully in some separate box. Therefore, we get expanding, this is a summation rule. So, x into dx plus 1 by integral 1 by x into dx minus 2 into integral dx. Therefore, this is again power rule. X dx is x to the power of 1 plus 1, that is x square by 2 plus 1 by x, integral 1 by x is log of mod x minus 2 into integral dx is x plus c. Next question. Evaluate integral x cube plus 5x square minus 4 divided by x square into dx. So, solution is the given equation is written down as it is. So, given integral x cube plus 5x square minus 4 divided by x square into dx. Therefore, dividing the entire thing by x square, the denominator, the numerator is divided by the denominator. Therefore, x cube by x square is x plus 5 as it is. This x square in the numerator and denominator, x square in the denominator get cancelled and we get 5 minus 4 over x square. So, 4 over x square can be written as when the x square goes to the numerator, it is minus 2. Therefore, the given equation becomes integral of within brackets x plus 5 minus 4 into x to the power of minus 2. Please write it separately and calculate yourself. Though I have explained all the steps, you can copy down and work out separately. Therefore, again, by summation rule, we can segregate it. Therefore, it becomes x dx, the first term. The second term is 5 into integral dx minus as it is. The constant 4 is taken outside the integration sign. Integral x to the power of minus 2 into dx plus c. Therefore, using the power rule, integral x dx is x square by 2 plus 5 into x. Integral dx is 5 into x minus 4 into this x square can also be the integral of x to the power of minus 2 can also be found out by power rule. That is x to the power of minus 2 plus 1 divided by minus 2 plus 1 plus c. Therefore, it becomes the equation, it is equal to x square by 2 plus 5x. So, here minus 2 plus 1 becomes minus 1. Minus 1 into minus, here this outside minus becomes plus. Therefore, 4 is copied as it is. This minus 2 plus 1 becomes x to the power of minus 1. And when x to the power of minus 1 goes to the denominator, it becomes 4 by x plus c. This is the answer. Question number 6. Evaluate x cube plus 3x plus 4 divided by root x. If you see, if you compare with the previous example and this example, there is a root x in the denominator of the question number 6. Let us solve it. Solution. The given equation is copied as it is noted down as it is. That is integral of x cube plus 3x plus 4 divided by square root of x into dx. Therefore, it becomes, if we divide it, x cube divided by root x into dx plus 3x divided by root x, here dividing by root x, plus 4 by root x, square root of x into dx. So, there are three integrals. First term, x cube by root x dx plus integral of 3x by root x dx plus 4 by root x dx. Therefore, this can be written as, this can be further simplified. We know every x root x is x to the power of half in the denominator. When it goes to the numerator, it becomes x to the power of 3 minus half. So, this root x, when we taken to the numerator, it is to the power of minus half. Therefore, x cube minus half dx plus 3 into integral. We are simplifying the given equation. Integral x into this x to the power of 1 minus half here dx plus 4 into 4 outside the coefficient of variable 4 into x to the power of minus half. This is minus half. Okay, this looks mixed dx. Next step is we have to simplify. That is using power rule. In power rule, we add 1. Therefore, the given function x is 3 minus 1 half plus 1. Therefore, 3 plus 1 minus half. It is rewritten as it is in this form. And the denominator is once again the same thing. That is 3 plus 1 minus half plus 3 into x to the power of 1 minus half is half plus 1 of the integration. So, it becomes x to the power of half plus 1 divided by half plus 1. And the third term is 4 into 4 as it is, x to the power of half divided by half plus c. Plus c is the constant of integration. We have removed the integration sign after integration, and we have to put a constant of integration, that is c. Therefore, now simplifying, we get it as x to the power of, simplifying, it is 4 minus half is 3 and a half. 3 and a half simplifying, we get it as x to the power of 7 by 2. divided by 7 by 2 plus 3 into x cube. 1 and a half is x to the power of 3 by 2 divided by 3 by 2 plus 4 into x to the power of half by half plus c. X to the power of half is written as square root of x in this line. Therefore, simplifying, it becomes 2 by 7. The denominator 7 by 2 becomes 2 by 7 in the numerator. 2 by 7 into x to the power of 7 by 2 plus this 3 and this 3 get cancelled and 2 remains. So, 2 into x cube to the x to the power of 3 by 2 plus this 2 and goes to numerator and gets multiplied with 4. So 2 into 4 is 8. Square root of x plus c is the answer. Next question. Evaluate x cube minus x square plus x minus 1. So this is a polynomial of third degree. Therefore, let us solve it. Given solution, given the given equation, function is copied as it is. Therefore, given is integral x cube minus x square plus x minus 1 divided by x minus 1 into dx. Therefore, integral, we take between these two terms, x square is taken common. So, we will simplify it. So, or factorize it. So, x square if we take common, it becomes x minus 1 plus 1 if we take common, x minus 1. So, the numerator is, after taking x square as common, x square into x minus 1 plus x minus 1 and denominator is x minus 1 as it is written into dx. Now, simplifying, we get this as x minus 1 of the numerator. This x minus 1 if we take common and this x minus 1 gets cancelled and the remaining part is x square plus 1. This x square plus 1 is written as shown in the screen. Therefore, x square plus 1 into dx. Therefore, integration of, again, this is a summation. So, we can segregate it. Algebraic summation. So, it can be written, this line, previous line can be written as x square dx, integration x square dx plus integral 1 into dx. Therefore, again, we have to use the power rule. Power rule is x to the power of n plus 1 divided by n plus 1. Therefore, n here is 2. Therefore, it becomes, the first term becomes x cube divided by 3. Plus, here integral 1 dx is x plus c. C is the constant of integration. Question number 8. Evaluate 1 minus x into square root of dx. Given. So, solution. Given equation is written down as it is. That is, given integral 1 minus x into square root of x dx. Next step is, we have to simplify this. So, it is, if you multiply 1 into root x is root x minus of x into dx. X is 1, x square root of x is x to the power of half. 1 plus half is 3 by 2. Therefore, the previous line given equation becomes within brackets root of x minus x to the power of 3 by 2 dx. Therefore, it is integral, this is x to the power of half, x to the power of half into dx minus x to the power of 3 by 2, integral x to the power of 3 by 2 dx. Therefore, again, using power rule, we can integrate it. Therefore, x to the power of, integral of x to the power of half is x to the power of half plus 1, that is 1 and a half, that is 3 by 2. X to the power of 3 by 2 divided by 3 by 2 minus x to the power of 3 by 2 plus 1, that is x to the power of 5 by 2 divided by 5 by 2 plus c. Next step is to simplify. This denominator becomes 2 by 3. 2 by 3 into x to the power of 3 by 2 minus 2 by 5 into x to the power of 5 by 2 plus c. That is the answer. Next question. Question number 9. Evaluate integral root of x into 3x square plus 2x plus 3. So within bracket it is a polynomial of the order of 2 or a quadratic equation. Outside is root x. Let us solve it. Solution. The given solution is written down as it is given integral root x into 3x square plus 2x plus 3 into dx. Therefore, multiplying the term, the variable term with the polynomial or the quadratic equation, we get 3 into x 3x 2 plus half. 2 plus half is 2 and a half, that is 2x to the power of 5 by 2 plus 2 into x plus 1 plus half 3 by 2. Therefore, plus 3 into here 3 into x to the power of half. This outside coefficient x to the power of half comes here. Okay. So the given equation is simplified and written as integral 3 into x to the power of 5 by 2 plus 2 into x to the power of 3 by 2 plus 3 into x to the power of half, that is square root of x into dx. So the coefficient or the constants are taken outside. Therefore, 3 is taken constant root, 3 is taken outside, integral x to the power of 5 by 2 into dx plus 2 into x to the power of 3 by 2 into dx plus 3 into integral x to the power of half into dx. Therefore, now we have to integrate. If we integrate using power rule says it becomes x to the power of n plus 1. N here is 5 by 2. Therefore, it is 3 into within brackets x 5 by 2 plus 1 is x to the power of 7 by 2 divided by 7 by 2 plus 2 into x to the power of 5 by 2, that is 3 by 2 plus 1 is 5 by 2 divided by 5 by 2 plus 3 into 1 plus half. 1 plus half is 3 by 2. Therefore, x to the power of 3 by 2 divided by 3 by 2 plus c. If you want, you can write separately, that is 5 by 2 plus 1, 3 by 2 plus 1, 1 by 2 plus 1. If you write separately and calculate, it becomes the same, whatever is we have written here. Therefore, it is 3 into 2 goes to the numerator. 3 into 2 is 6 by 7 into x to the power of 7 by 2, which is as in the previous line, plus this 2 goes to numerator. 2 into 2 is 4 divided by this 5 in the denominator into x to the power of 5 by 2, as it is, as in the previous line, and then this 2 goes to the top. 2 into 3 is 6. This 3 and this 3 gets cancelled and 2 remains. Hence 2 into x to the power of 3 by 2 plus c. That is the answer. Next problem. Evaluate integral 2x minus 3 cos x plus e to the power of x into dx. Hitherto, we are getting simple linear equations or quadratic or polynomials, and with simple divisions and simplification. Now, we are getting the equation in terms of trigonometric and exponential function. In the given equation, you see the first term is a term containing x, and the next term is a trigonometric, and the third term is exponential. So we have to remember all the three formulas. So let us solve it. Solution. Given equation is copied as it is, integral 2x minus 3 cos x plus ex into dx. Therefore, it is the coefficient or the applying constant rule, the constant 2 is taken outside and it is written as x into dx minus 3 into integral cos x dx plus integral e to the power of x dx. Now we have to integrate. Now integral 2 is as it is 2 into power rule x square by 2. Therefore it is 2 into x square by 2 minus 3 into, we know, cos of integral cos dx is sin x. Therefore it is written as sin x. And integral of e to the power of x is e to the power of x itself. So it is written as it is. Therefore, simplification, after simplifying, these 2 and these 2 get cancelled and we get x square minus 3 sin x plus e to the power of x plus c. Next question. Evaluate integral 2x square minus 3 sin x plus 5 into root x dx. Therefore, given integral 2x square minus 3 sin x plus 5 into x dx, that is given equation is copied as it is. Therefore, it becomes 2 into integral, this we have taken outside, 2, that is constant rule, 2 is taken outside, integral x square dx minus 3 into sin x dx plus 5 into integral root x dx. Therefore, it becomes power rule 2 into x cube by 3 minus 3 trigonometric function. Integral sin x is minus cos x. So, it is written as, you have to remember, minus cos x plus, you see, x to the power of half. X to the power of half is int plus, that is power rule again. That is x to the power of half plus 1 divided by half plus 1. That becomes 5 into x to the power of 3 by 2 divided by 3 by 2 plus c is the constant of integration. So, constant of integration should be written only after integration, not before that. You cannot write it here. You have to write after removing or after integrating the previous line. So, it is written here. Therefore, simplifying 2x cube by 3, this minus into this minus, outside minus and inside the bracket minus becomes plus. Therefore, 3 cos x plus this denominator 3 by 2. When 2 goes to the numerator, it becomes 2 into 5, 10 divided by this 3 into x to the power of 3 by 2 plus c. Next question. Evaluate. Now it is a pure trigonometric function. Evaluate integral secant x into secant x plus tan x dx. Therefore, let us solve it. Given equation is written down as it is. So, integral given integral secant x into secant x plus tan x into dx. Therefore, secant x into secant x becomes secant squared x integral secant squared x plus integral secant x tan x. Therefore, we know from our standard formula integral secant squared x dx is tan x and integral secant x tan x is secant x plus c. Next question. Evaluate secant squared x cosecant squared dx. Therefore, given equation is copied as it is. Now we know secant squared x is 1 over cos squared. From our trigonometric knowledge, we know that secant squared x is 1 over cos squared x and cosecant squared x is 1 over sin squared x. So that becomes, this goes to numerator and this becomes denominator. Therefore, the given equation is integral sin squared x divided by cos squared x dx. Therefore, sin by cos is tan. Therefore, it is tan squared x. This is once again simply using the trigonometric relationship. Therefore, we also know that tan squared x is secant squared x minus 1. Therefore, we are writing this is integral secant squared x dx minus dx. Therefore, that is tan x. Integral secant squared x is tan x. From the standard integration formula, tan x minus x, that is the standard forms, minus x plus c. C is the constant of integration. Question number 14. Evaluate integral 2 minus 3 sin x divided by cos squared x dx. Therefore, let us solve it. Given integral 2 minus 3 sin x divided by cos squared x dx. Therefore, this is integral, separating this 2 minus 3x, we get 2 by cos squared x dx minus 3 by cos squared x sin x. Sorry, this is minus 3 sin x divided by cos squared x. This is 1 by cos squared x is, this 2 is taken outside, 1 by cos squared x is secant squared x minus this 3 is applying constant rule, 3 is taken outside, minus 3 into sin x by cos squared x. So sin x by cos x is tan x and 1 by cos x is secant x. So the second term, the above second term becomes minus 3 tan x into secant x dx. Therefore, this is 2 of integration, we know from the standard formula, 2 into tan x, that is integral of secant squared x is tan x minus 3 into tan x secant x is secant x plus c. Question number 15. Find the antiderivative of square root of x plus 1 over square root of x. Given. So, given equation is copied as it is. Therefore, it is root x plus 1 over root x into dx. Therefore, separating and integrating and separating, we get integral of root x dx plus 1 by root x dx. Integral 1 by root x dx. Therefore, it is integral x, under root x is x to the power of half, integral x to the power of minus half. This is minus half dx. Therefore, integral x to the power of half is x to the power of 3 by 2 by 3 by 2 plus x to the power of minus half becomes, if you add 1, it is 1 minus half is half. So, this is x to the power of half divided by half plus c. Therefore, simplifying, we get 2 by 3 x to the power of 3 by 2 plus 2 into x to the power of half plus c. Next question. Now, we have solved 1 mark question and 2 mark question. Now, we will take up one 3 mark question. Given, if d by dx of fx is equal to 4x cube minus 3x to the power of 4 such that f of 2 equal to 0, find fx. Here, d by dx of fx is given. And it is also given that if x is equal to 2, f of x is 0 and we have to find the fx. So this f of 2 equals 0 will help us in calculating the constant of integration. Let us do it. Solution given d by dx of fx is given 4x cube minus 3x to the power of 4. Therefore, antiderivative of fx is integral 4x cube minus 3 by x to the power of 4 dx. Therefore, f of x is equal to this using the constant rule, 4 is taken outside. 4 into integral x cube dx minus 3 integral x to the power of 4 is in the denominator, it goes to the numerator. Therefore, it becomes x to the power of minus 4 dx. And therefore, fx is 4 into x to the power of 4 by 4 using power rule. That is, integral x cube is x to the power of 4 by 4. That is, we have to add 1 in the power as well as in the denominator. Minus 3 into, here also we have to add 1. But here minus 4 is there. Minus 4 plus 1 is minus 3. X to the power of minus 3 divided by minus 3 plus c. Plus c is the constant of integration. Therefore, simplifying, we get f of x is equal to this 4 and this 4 gets cancelled, x to the power of 4 and this minus becomes plus, 3 and 3 get cancelled and x to the power of minus 3 in the numerator when moved to the denominator becomes 1 over x cube plus c. C is the constant of integration. Let it be equation 1. Now we have found fx. So what was given was the d by dx of fx. Now what we have found? Fx. It is also given that f of 2 is equal to 0. That is, if you put x is equal to 2 in this equation, we get right hand side equal to 0 or left hand side also equal to 0. It is given f of 2 equals 0. Therefore, putting x is equal to 2 in the given equation, we get f of 2 is equal to 2 to the power of 4 plus 1 over 2 cube. 2 cube is 8 plus constant of integration as it is. It is not given. So, that is also given f of 2 is equal to 0. It is given. Hence, we put f of 2 equal to 0 on the extreme right hand side. Therefore, we have to calculate c from this equation. Therefore, 2 to the power of 4 is 16 plus 1 by 8 plus c is equal to 0. Therefore, we calculate from this equation, we find that c is equal to minus of 129 by 8. Therefore, f of x is equal to the given equation. This is not given, equation 1. F of x is equal to x to the power of 4 plus 1 over x cube minus, we have to substitute the value of c is equal to minus 129 by 8. That is the